lecture series Programming in C. In this series, this session we will be looking about one dimensional arrays. In this module, we will learn about arrays whose definition and example, single or one dimensional arrays, declaration, initialization and its example. The definition of array says that an array is a collection of elements of the same type that are referenced by a common name. Generally, if we want to store some elements of the same type, it will be difficult for us to create n number of variables and to assign the values to every variable sequentially. So, that would be corrected by the collection of elements storage in the form of an array. Compared to the basic data types like int and float, it is an aggregate or derived data type. Why do we call it as derived data type? Just because that it is not going to be a single value, it is going to be a collection of values stored with the help of a basic data type. So, that is the reason that we call arrays as a derived data type, which adds the properties to the basic data type. All the elements of an array occupy a set of contiguous memory locations. So, if I start storing the elements of the same type from a particular memory location, say for 10 elements, for next 10 contiguous memory locations will be allocated for storing the elements of that array continuously. So, why do we need such type of arrays? So, let us consider an example scenario. We have a list of 1000 students' marks of an integer type. If using the basic data type int, if we are declaring something, we may have to declare it as in the given example. So, what am I supposed to do? I am supposed to declare the student mark 1, student 2 mark 2, student 3 mark 3. So, up to students 999 I have to store, I have to create n number of variables. So, this would be a difficult process to handle more number of students or more number of any entities. So, for storing the elements or the marks of 1000 students, we can create a single array with the name studMark of having 1000 elements storage. So, this will create 1000 contiguous memory locations and every student's mark is stored in each location. So, here what happens, we can see here that as a memory part, so stored mark of 0. So, this indicates the subscript of the array. The subscript of the array will be used to mention what element it is. So, from 0 we will be using the subscript of that array. So, 0 subscript will indicate the first element, which is going to be the first student's mark. Then stood mark of 1. So, if I represent here, 1 subscript will be denoting the second mark of the second student's mark, and third index is referred as a third subscript value is 2. So, this will indicate the third student mark. So, likewise we can make use of the index as 0, 1, 2, 3 in order to represent what element it is. So, in the stored contiguous memory location starting from 0 to 999, the student's mark can be stored in a contiguous memory location using a single data structure, an array. What sort of data types we can have in C language? It is named a simple data type, which includes int, float, char and double. Derived data types includes arrays, structures and unions. So, since array uses a contiguous memory location and it is going to store collection of elements, we can classify arrays as the derived data type. There are several operations that are allowed on the array like read, write, search, finding the sum of elements, finding the minimum of elements, finding the maximum value of the elements. sorting the array. So, these are all various operations associated with the array element, and the arrays are of basically two types. We can classify that as one dimensional array and multi-dimensional array. One dimensional array will include only one element for storage. Say for example, we can declare the one dimensional array using the syntax data type name. We have to use a square bracket. This square bracket symbol will actually denote that it is an array. So, the size inside the array will be used to denote how many number of maximum elements we can store using the array with the name defined as name. So, I can just declare the array name as type data type, what is the array name we want to go for, and what is it's going to be the size of the array. So, this statement is actually called declaration of the array. So, what it is going to convey to the compiler is that what is the array name and what is going to be the maximum number of elements that is going to be stored in that array, and what data type the array is going to hold, or what type of element the array is going to hold. So, these are the three informations that are carried over to the compiler. It is conveyed to the compiler. Then if we are trying to even supply values at the time of declaration to the array, or if we are trying to declare or initialize the array elements, then it is called array initialization. So, this process is called array initialization, wherein the array elements would be assigned at the time of declaration. So, while declaring the array itself, if you are giving values to the arrays, what are the values that are going to be stored in that array, then it is named as initialization of the array. So, as we have seen, type denotes the data type, name is the name of the array which is given, that is user defined. It can be anything according to the norms of the identifier. Size represents the number of elements that can be stored in the array. So, let us take one example of creating one dimensional array int x of 3. So, if I say int x of 3, three information are conveyed to the compiler, that the name of the array is x, the data type that is going to be stored in that array is going to be integer type, and it is going to be of using 3 memory cells. So, immediately what the compiler will do, the compiler will allocate 3 memory locations for this array. The array will be named with the name x. So, immediately what happens, the base address or the starting address of the array will be associated with the name x. So, whenever we are trying to access that array, we can do it only using the array name. So, supposing the index will be from 0, 1, 2. Supposing when I am trying to access the element 3 of the array x, so how can I do it? I have to refer it as x of 2. When I use the name x, the base address of the array will be associated with the name x. So, the compiler will be able to identify from which particular location the memory starts, the memory allocation starts for the array. So, if it is defined, if it is done, then we can make the subscript element. Suppose if it is 2, from the base address we will be adding 2 locations to reach the exact required location. So, from the base address, let us assume that the base address is 5000. So, the base address is 5000. So, when I am trying to reach the element or third element of the array, the base address will be added with the given subscript. The subscript value is 2. So, 5000 will be added with 2. So, we will be getting the address as 5002. So, which will be actually 5002. This will work out if the integer element or single element of the array occupies one memory location, whereas we have defined the integer type data to be stored in the element, we have to calculate what is the size of each element of integer type. If it is going to be 2 bytes, accordingly the memory location will be calculated using the base address to reach the particular subscript. So, this is a way we can access a particular element in an array. More than one array can be declared in the same line as int age of 10, height of 10, names of 10. So, all these 3 arrays would be carrying of the data type int. We can even declare the array in alliance with the declaration of variables. So, int I and j, these two are the variables. So, the array declaration even be combined with the variable declaration. Then, how do we initialize the array? So, generally we will be using the syntax int the array name of maximum number of elements semicolon for the declaration of the arrays. So, instead here you are supposed to use the equal to operator and use a curly braces to store the elements while declaring. So, this is the way we can initialize the array. So, here we can see that the array y is initialized with values 2, 4, 6, 8 at the time of declaration of the array. Similarly, we can take a second example that int age of 10 is declared with all elements to be zeros and int age of 10 with only first element to be 0, one element to be 0. You can leave, it is optional to assign values to the array elements. If you want, we can assign one value or all the values, that depends on the user's requirement. Then in the example 4 we can see that int age. So, here there is no subscript given, even then the base address would be considered and automatically the array elements would be stored in the contiguous location starting from the first location in this case. Then, how do we access an element in a one dimensional array? So, as we have seen in the previous example, if it is going to hold 3 integer elements, it is stored in the contiguous memory locations as per the example 24, 20 and 10. How do we access the particular element? Supposing if we want to access the element, middle element of the array, then we need to mention the subscript corresponding to that element. If the subscript starts from 0, 1, 2, then the element 20 would be accessed using the notation x of 1. So, this is how we can access a particular element in a one dimensional array. So, here in this figure we can see that the elements 24, 20 and 10 are stored in the respective index values 0, 1 and 2. So, if we want to represent the first element of the array x, it is x of 0, the second element it is x of 1, the third element it is x of 2. Then let us take an example of an integer array with 10 elements and which is being initialized with first 3 elements. Then how the memory treats the array, how it is created. So, let us focus on that. So, since the array is created with 10 maximum elements, 10 contiguous locations will be allocated for the array C, starting from the index C of 0 to C of 9, out of which we can see that the first 3 elements of the array are assigned with the values 24, 59 and 35. So, 24, 59 and 35. So, these are the first 3 elements of the arrays assigned in the memory. Even then It has 10 contiguous locations, only the first 3 elements has been filled. Then how we are going to retrieve an array element from the memory? We know that the memory will be associated with contiguous location storage because of the concept of arrays. So, here we can see an example of considering an array named as L with 5 values. So, here we can represent the subscript using the notation L of 0, L of 1. L of 0 will print the first element since it is given as an input in the printf statement. So, percentage %d first, percentage %d will be replaced with L of 0, which is having the value 1. The next L of 1, which is having the value 2. So, first 2 elements are displayed and it goes with the loop. In the loop, it runs for 5 iterations starting from I value to be 0. So, when the I value is 0, it enters a loop, it prints the value of L of 0. It means that this I value is replaced with value 0 for the first iteration. So, it looks for the value of L of 0, which is 1, okay, which is now again displayed, and now the loop is getting iterated for the next time. So, by the time I value is incremented by 1, so I value becomes 1. So, when it comes inside the loop L of I, so now it is represented as L of 1. So, L of 1 is nothing but the value 2. So, it displays the value 2. Then again the loop will be iterated with being the I value to be 2, it is incremented by 1. So, it displays the value of L of 2, L of 2. So, L of 2, it is nothing but the value 3. Then again the loop will be iterated. As of now, I value becomes 3, which is incremented. When it comes inside the loop, it is going to display or print the value of L of 3. Okay. So, L of 3 is now 4, L of 3 is now printed as 4. Then again the loop will be incremented. Now, I value becomes 4. When it enters the loop, L of I is now replaced with the value 4. So, L of 4 will be displayed. So, L of 4 represents the value 5. So, it is displayed 5. So, this is what will be the output which we will be getting on accessing the array through 2 ways. The first method is we can directly represent the subscript and we can print the corresponding element. The second method is we can go with the loop. The loop will start from a initial value and how many number of iterations you want to continue. According to the loop termination condition, we can end up the loop. So, here we can see that the size of the array which is declared is 5. So, the loop has to be run from 0 to 5. So, when it encounters 5, because the subscript starts from 0 to 4. So, the loop has to be terminated at when I becomes 5. Then we will see one more example on reading the values of an array. How we are going to read the values and how the values are going to be stored in the array. So, let us assume an array with the name ARR of 10. So, here we can store maximum 10 elements in the array with the name ARR. So, what happens for accessing or for reading the 10 values, I need a loop, or otherwise I have to use the scanf statement and I have to read the values individually as ARR of 0, ARR 1, ARR of 2, ARR of 3. So, likewise I have to read individually. So, instead we can make use of a for loop starting from 0 ending up to 9. We can read the values of the array using a simple scanf statement. So, like this, so scanf %d ampersand ARR of I. So, I will be replaced with the value starting from 0 to 9. So, ARR of 0 to ARR of 1 we can 9 we can read the values and we can store it in the contiguous memory location. And if we want to calculate the sum of all the elements which are stored in the array. So, how this can be stored, how this can be done? Again we can make use of a for loop. In the for loop, sum equal to sum plus ARR of I. Okay. So, what happens here? The I value, index value keeps changing from 0 to 10. So, initially at the first step, whatever the value which is stored in the element ARR of 0 will be added with sum, then ARR of 1 will be added with sum, then it goes on up to ARR of 9. So, all the elements will be added and the cumulative sum will be stored in the variable sum. So, thereafter we can just display the variable value sum. So, here again we have gone for two operations. One is that we have read the values of the arrays and stored it in the array, and the second step is we have accessed the values that are stored in the array and we have calculated the sum of the elements in the array. Then we will see one more example wherein the stored marks of the students accessed in an array and we are trying to find the minimum marks and maximum mark of the students, and also we are trying to find is there any two students who are getting the same mark. So, what here we are doing, as in the first step we are again defining the array with 10 elements and using the scanf statement as in the previous example we are reading the values of 10 elements, right. And now we are going to run a loop from 0 to 9 and here we are trying to store the value of the first element in the variable x, and we are going to use a loop from j equal to I plus 1, in the sense that if I value is 0, j value will be 1 to 10. It means that I am taking the first element of the array that is compared with the remaining elements of the array. So, whatever the value, supposing if 23 is going to be in the first location, the first subscript, 23 value 23 will have to be compared with all the other remaining elements if there is going to be a match. So, we can see that in the fourth location there is a match of the value which is there in the first element. So, what happens? The loop will check for the equality of the value with the array element which is checked subsequently. So, what happens? It is going to search for the element 23 which is equal to ARR of 3. So, it has found a match. If it finds a match, then we can just simply give a message that number appeared more than once. So, with that we can stop executing or stop continuing this loop. So, similar to this operation, we can make use of the concept for finding the minimum value and the maximum value. The only thing that we are supposed to change here will be the equality operator. So, instead of equality operator, if we are considering the relational operator like equal, greater than or less than, we will be able to calculate it for finding out the maximum and the minimum values of the given set of numbers. So, this example is to, as we have already seen, this example is to store the access the students marks and finding out the maximum and minimum values. So, here instead of equal to operator we can make use of the greater than operator to check if the number of students are going to be having maximum value and what is the actual number of students. If we are trying to enter more than the actual number of students, we can give a notification saying that too many students are there in that particular term entry. So, we can make use of the relational operators for comparisons. Now, use an integer to store the current size of the array. How do we store, how do we keep track of the number of elements of the array? Because in the previous example we can see that what is the actual number of students if we are defining it to be 5, but then if we are trying to enter the number of values even more than 5. So, we can't keep restricting the users to enter, but of course, we can check the values after entering and then we can stop, or we can give an error notification that too many students mark entry is being done. But is there any way that the size can be defined in a different way? Yes, it can be done. We can make use of hash define statement to store the maximum number of students or maximum number of entry elements that can be stored in an array, and we can make use of the constant max in wherever the way that you want to define the size. So, instead of having the size as an integer value, we can even have the constant value which is defined using the hash define preprocessor directive. So, on summarizing this session, what we have learnt is, we have learnt that arrays are the data types, which arrays are the data structures which can have collection of data elements into a single entity, into a single data structure, so that all the data values which are going to be stored in the array, it is going to be of the same data type. And one important feature of arrays is that all the elements of the arrays can only be stored in contiguous memory locations. So, this will help us reduce the number of variables defined in a program in case if we want to handle more number of elements or a list of elements. So, those cases we can go for using the arrays as the data structures, which will be an efficient data structure to handle in case if all the elements are of going to be same type and if it is going to be more number of elements. Also, we have learnt the concept of using one dimensional array. So, how we can make use of one dimensional array to create a list of elements. So, we have gone through the declaration part, we have learnt the initialization part, and how array elements are getting stored and how the array elements are being retrieved from the memory locations. Also, we have seen examples on doing processing on arrays, say like finding out the sum of elements, finding out the number of elements, maximum number of elements, minimum value. So, likewise we have even seen the operations with respect to the array. Thank you for listening.